Nisha introducing him. Do you know how to
So you log in and then go to the webpage.
Yeah, I saw the.
Agenda and go to the keynote and click on it and you'll see the thing. So what you can just we can just talk about a little bit about the program and then what is
The rest of the program today.
and take 5 minutes please because I need to make sure that the live stream link is correct.
Oh, okay. All
Take
right.
your time.
Right.
Yeah.
Hey, how are you? Good morning. So we need to connect first a Mac, and then we will switch to.
You guys need
I
the
think it's the same VGA is enough.
yeah. That's a VGA port.
That's a VGA.
Okay, I'll switch it back.
Let's see. So, do I need to do something? I guess.
You might want to make sure you're up first before you open up a bunch of things. You know what I mean? Because right now it's not reading you.
Okay. So do I open something maybe and then see?
Go to your displays because it's not outputting right now. You see what I'm saying?
Yeah, I see. Let me. Okay. I mean, there's usually what is it? Function something to. Let's see. Here's my display. I think
Yeah,
it's
bring
in
your
settings.
displays up. Go displays.
Yes, that's display.
Right here.
You can see it. All right. So
Okay.
let's see what we got.
So it's not.
Usually it does not has no problem displaying it.
Here.
Let me open PowerPoint and see if that works actually. If it does, then
Most Macs, when you bring that up, it has a submenu that says arrangement, and that's where you go to mirror. That's basically you got to mirror or duplicate your desktop where it's sending.
so display. That's all. Display scale. Show. Maybe it's not display. Maybe it's desktop. Maybe.
So I just switched it to VGA. Should be
Okay, so Alex, go ahead and lock up your bad deal and barrel that you're in right now, and get ready
Other option we have.
we need to do.
Okay.
Here's a
Oh, pointer.
pointer and a receiver for it. It's working.
So here's display. Scale.
That wouldn't be bad. You just got to somehow you got to duplicate your desktop and make sure you're sending.
Don't we have some?
Put it into presentation mode or.
Yeah. One of my students who uses a Mac extensively would do that.
Yeah, I'm not the best with Macs. I do know. Sometimes I fool with them and I get it right.
Okay, I'll tell you.
Yeah, he's not sending, I don't think, in display mode.
The mirroring should be done before. Yeah, I know. For some reason it's not taking. Let's see if you want to start something.
We might with a Mac a lot of times too. I just reboot it and it comes right up. You know,
You could do that.
once you got it hooked up, if you just reboot.
So once you connect it, it should
See,
come
'cause-
up. It's not coming out. So if I start the presentation, let me just do it. It's just to restart it. Just hit enter. Well, I wanted to reopen Windows. Okay, restart. I think it may.
Another thing I could try, and this is, I could try one of our adapters too at the last minute.
Is this VGA?
Yeah, it's going to VGA. We have one that goes from that same port to HDMI. I believe we did. Run it down.
I think it needed to restart with some problems.
It does. Some of the guys have these Macs that when you go to your display, it comes up and there's a submenu that says arrangement, and
That's
then they hit on that and it.
That happens once it recognizes the setup.
Okay.
It
Okay.
not recognize.
Pardon me?
HDMI is more reliable compared to VGA.
Yeah, because
Well,
this is digital out.
Let's just take it and connect his laptop directly. This way we don't have to worry about Mac issues.
Yeah, VGA port.
Yeah.
There you go. Here's your
The remote adjuster.
It's okay, I can.
the lights. Oh, you don't need it.
He gave me
You got your
the-
own. Okay.
I think, you know
You
what?
good?
I'm gonna connect this thing.
You still remember your settings? 313 first. Yeah. Okay. Oh, that's 2. That's for your panel. You want 3. All right. Good. Thank you. Good. I'll leave this here just in case you guys want it.
What is that?
The
pointer?
Yeah, they call for a pointer, but you got to engage this as well. But-
Yeah, that's fine. Thank you.
And it's already turned on. Okay. Should be
So
good.
We're good for.
Yeah, well, just, you know, you can just talk about, well, it's just, all right.
Let me just, I'll say it.
Yeah,
Just leave it
yeah.
here. So just a moment. There's just a couple
There's
of
a
items. I
readout.
guess. Readout after the keynote, right?
So we,
And then the panel. Wait a second.
we have keynote and then readout and then
Big
panel.
panel, and
So
then
readout for all the 3 breakouts. Somebody has to come in and read out, 10, 15 minutes at most, and then the panel 2 discussion.
Okay. Just leave this. Okay, well, good morning, everyone. Sorry for the late start. We had a few technical issues. I overly trusted my Mac, I guess. So this is the second day. It's actually a half day of our workshop. And before I introduce our keynote speaker for the day, just to remind you for the day's agenda. So following the keynote, we're going to have the readout from the breakout sessions. Those of you who participated in yesterday's breakouts, we had 3 breakout sessions, and we're going to hear from the leads from these breakout sessions in terms of the conclusions and the items that were discussed. Then we'll have our second panel in this meeting, which is focused on furthering academy and industry collaboration and looking at moonshot millimeter wave RCN contributions. Then we're going to have our lunch and we'll conclude the meeting. We also have, as a reminder, we have a hands-on workshop from 1 to 4 p.m. by National Instruments, which will take place also in this room. This is particularly useful for students, but everybody is invited to attend as well. So, okay, can we show a show of hands of how many people intend to attend the workshop in the afternoon? I would say maybe 20, 15 to 20. Okay. All right. Okay, so let me introduce our distinguished speaker, Dr. Carlos Cordero from Intel. So Dr. Cordero is a senior principal engineer and senior director in the Next Generation and Standards Group within Intel Corporation. His short bio is actually displayed on the web page for the conference, and we wanted to show it here, but we had this small glitch. Currently, he heads Intel's Wi-Fi Alliance efforts and Intel standardization for unlicensed millimeter wave frequencies. Within the Wi-Fi Alliance, he is a member of the board of directors and serves on its technical advisors. He's also chairing the technical task groups on the 60 gigahertz. This is the unlicensed band, one of the unlicensed bands in the millimeter wave in the spectrum. He was a technical editor to both the IEEE.11ad standard and the Wi-Fi Gigabit Alliance for Mac and Phi specification. Currently, he's a technical editor for the IEEE 802.11ay standard. He has a long list of contributions and achievements that I will, in the interest of time, I will leave you to read them on the webpage of the conference. So without any further ado, I would like to introduce Dr. Carlos Cordero. This one.
It's okay.
This is your.
All right. Yeah. This is better. This is a mobile microphone. Okay. Okay, good morning, everyone. I'd like to thank Monisha and Akbar for inviting me to be here. It's great to see that, there's a lot of people that are actually interested in millimeter wave. I've been working on millimeter wave for 12 years, believe it or not. I see more and more people working in this area. I feel that I should have left, sorry to say that, but many years ago, but I keep on doing it because I'm actually excited about it. So, I have a few slides. I know you're all experts on millimeter wave. I do have a few introductory slides in the beginning to just motivate. I think, I don't think I need to spend too much time on motivating why we need millimeter wave. And then we'll dive into the some of my perspectives of how millimeter wave has evolved over the last 12 years since I've been involved in it. And I've seen ups and downs over time. And I'm not just going to show you that it's a beautiful area that's going to be exploding in the next few years. Actually, there are some challenges ahead. There are some challenges we've seen even in the last few years. And I also like to, put some perspective on those. So let's start. I think, I think we all know how things started. The evolution of communication in the beginning was all you could do was to send a text message, and folks have phones and, saying, hey, text message was really what the main use case when we started using our phones. And then after text, we saw the emergence of photos, and it started taking more bandwidth, and people wanted to exchange photos. And then we had evolutions from, first generation, second generation of cellular, and Wi-Fi was getting faster. Then we see the emergence of more use of video, and now capacity starts to increase. You need to send more data. You see, things like 3G and LTE coming to bear, and Wi-Fi, on the indoor side. And where we see this going forward is that now it's going to be moving to more, augmented and virtual reality, where things really get more interesting in terms of data rates. You really need a lot more capacity, and that's now where we see the emergence of technologies like 5G and faster faster Wi-Fi. And so these increasing data demand, which is not new to any of us, has really been the motivation why we've been looking at millimeter wave. How can we pump more data into the pipe? This is data demand that is widely available, widely known. We just select here 3 places. As you can see, just the amount of data per month in these different locations that we need to carry. And this is just growing over time. So the reason for millimeter wave that you all know, it's all about, we can get more capacity, 10, 20 times faster than what you can get in frequencies below 6 gigahertz. When you have more capacity, lower latency, you have better user experience. So, it's a simple story. It resonates with a lot of people, and that's why, the industry, the academia, and all of us are interested into this topic. Main spectrum bands that have been talked about for millimeter wave have been, all the way from, 20. This is more the U.S. view, but different locations in the world, it's all around 28, 37, 39, and the E-bands for licensed. And we have these unlicensed band, which is the so-called 6 gigahertz unlicensed band, as you can see there in the figure. So this is why we do millimeter wave, and I think it's a great motivation. There's a lot of innovation that can be done there, and there's a real need for higher capacities. So what has the industry been doing over the last few years in this area of millimeter wave? There's been a lot of activities around standards, and really that's the place where I'm going to spend more time talking to you about. Is the work that we've been doing in the industry to accelerate this technology, to come up with something that works across devices, across vendors, so that we can really bring this technology to market. And when it comes to standardization, you can see it from the 2 main groups that are developing technology for millimeter wave. One being the IEEE, which started the millimeter wave standards development over 10 years ago. There are already commercial products in the market that are using this technology, in particular the 11AD. I assume that most of you have heard of it. So these are products that are in the market. There is a new project called 11AY that is evolving this technology to become faster and lower latency. That I'm going to be talking a little bit about it. And of course, we also have the 3GPP, which has recently, also been working on its own millimeter wave specifications. As Intel, we believe that we believe in supporting both technologies, and that we are really investing to make sure that we bring these 2 technologies to market for the benefit of users. However, just for the purpose of this presentation, since the 3GPP technologies are much in the process of development, I will focus more on the IEEE side, and also being the one that I'm more closely involved. So I'm just going to try to give an overview of what the 11AY project, which is evolution of 11AD, what we are working on. I'm going to be, I'm going to be giving a very high-level technical review based on the time that I have available. But I'm going to be really trying to focus on the challenges and that go beyond technical challenges. So we're going to spend some time there. And I also going to be touching on where do we go from here, what's next, and how do I see, and that's my personal opinion, this millimeter wave market going forward. Okay, so this slide is very, it's a busy slide, but it does summarize in one slide, what 11AY provides on top of what is already available today for 11AD. On the, you can see this broken out on the left-hand side by, the MAC, medium access, security, the PHY, and beamforming. And then, there are sub-features. I have this. There are the sub-features here, which, hopefully they are self-explanatory. The architecture, the medium access, power saving, aggregation. Then we get to the security, and then the PHY in terms of modulation, channelization, and so on, and then beamforming. And this is what 11AD, right? This is what is available today. In many products offer this set of features here. Well, not all of them in some cases, but a good set of these features. And this is what 11AY is providing now. Okay, I'm going to quickly go through this because and highlighting some areas which I think it's relevant to mention. And I'm going to actually start from improvements on the medium access, where we are doing more and more things like aggregation and to allow basically higher capacity. The more you can aggregate in terms of data packets, the more you can send. There are some improvements in terms of in platforms like phones and tablets and PCs. There is an inherent limitation that whenever you want to send data, if the data goes through the OS and the OS has to manage the data transfer, things become slower. So we've done some improvements so that you don't have to go through the OS, you don't have to go to the host. You can go directly from memory to the NIC, and that really allows you to exploit more the capacity that the radio provides. So there are some platform level improvements. In terms of the physical layer, we still keep, like 11AD, we still keep the single carrier as the main modulation. There have been some additions in terms of non-uniform constellations and also an 8 PSK. And these are for applications that you have limitations in terms of PAPR for things like backhaul that you want to send more power, and you want to make sure that the OPA can go to that. Some modulations are better than others, so 8 PSK was one of those. In terms of capacity, so what we are doing there is now, the 11AD only supports one channel, one channelization, which is the basic channelization of 2 gigahertz. In 11AY, we are going all the way from 1 channel to 2 channels to 3 channels and 4 channels. Okay, so the capacity is going to be increasing, linearly based on the channelization there. Not only that, we are also working on, and this nomenclature here means aggregation. These are contiguous channels, the 432, 648. This is, and I'm going to show on the next slide. These are contiguous channels, but these are aggregated channels, so you can actually have gaps in between. So you have a more flexible way to use the band. So you can imagine that the capacity is going to increase much more because of these wider channels. It also supports MIMO, up to 8 spatial streams. And in terms of data rate, what this gives you is that it gives you a theoretical data rate that it's around 275 gigabits per second. So as you can imagine, as you can see, it's a pretty high data rate theoretically when you go to the maximum configuration of 4 channels, 8 spatial streams, you do short GI, and you take the the max, the highest modulation and code rate. Okay. Now it's theoretical. We all know the caveats around that. In practice, we really don't get to those rates. More realistic rates for initial deployment is probably going to be around 15 gigabits per second. Using two-channel bonding, and that's something that's more realistic, at least for initial product releases. And then, of course, over time, those data rates will increase. 11AD from start, they start using LDPC. We keep with LDPC. We're just increasing the code word, gives you better efficiency, around 0.7 dB better performance. GI, we also have short, normal, and long GI. This was to cater to applications where you can really go short range, or backhaul applications where you really want to go longer range. So we have different GIs that can deal with different channels. And beamforming, this is an area where the group has really, and it is spending a lot of time. We had a basic beamforming protocol in 11AD, which, again, hopefully most of you have heard of, called the sector sweep and the beam refinement. For 11AY, there were, I would say, even 3 tracks, and I have a slide later that is gonna be talking about that. We try to improve the existing protocols to make them less, take less time. We had to develop new protocols to deal with things like MIMO, as you can imagine. I mentioned that 11AY supports MIMO. So now you have to train multiple paths so that you can form multiple streams. So that was another area of focus in the group. And lastly, we also try to have beamforming that can be different for different applications. Some applications, and I'm going to be mentioning one later, you're not really interested in this path with the best signal strength or the best SNR necessarily. Some applications you may be looking for example, the shortest path. So there are these different ways of doing beamforming depending on the application, and if you bear with me for some time, I'll be covering that. All right. So just a little bit more detail. So that was the high-level overview, and I'm just going to quickly go through some more details on how it works, some curves, so that you can get a feel for how the system works. So this is the channelization, and I mentioned the channelization in the previous slide. This is how it looks like, if you just put a diagram together. This is what we have available in 11AD today and also in 11AY. You get wider channels. This is how they look like when you stack them up. What is important here is that everything that you do in 11AY has to be backwards compatible with 11AD. So if you have an 11AD device on the channel, and another 11AY device comes onto the same channel, one should be able to detect the other. It's exactly like you have today with 11N, 11AC, your Wi-Fi that you have at home, the Wi-Fi that you have in this building. Whenever you upgrade your access point, whenever you have new devices, they're not clashing each other. They're actually working with each other. So everything has been designed with this concept of we need to be nice neighbors to whatever else is out there. In this case, the whatever else was 11AD, in the case of 11AY. And that gets reflected in the packet format. So, this is the packet format of 11AY, and it has this portion here in the beginning, which is called the legacy portion. And this legacy portion is the same legacy portion of 11AD. So it allows 11AD devices to actually detect that there is something going on the channel, they can differ, and you ensure coexistence. And only after that, that's where you have the 11AY portion. So how does this look like on a spectrum, right? So let me show this because I think this is actually a much better way to see it. This is when you have two-channel bonding. This is how it looks like the spectrum of the packet. As you can see, this is one channel and this is another channel because you have two channels altogether to your bonding. And the initial part of the packet is just like a single channel transmission. So an 1180 device, it can detect that, and only when you go to the data portion is where you get a wideband signal. Okay? So this is how we do, again, 11AD, but that's how we do in every other Wi-Fi system that's trying to coexist, in this case with channel bonding. And this is what happens when you go to 3 channels and then 4 channels. So your preamble, the legacy preamble, the legacy device can detect, everything is going to work fine, and then you go to the payload and you get a much wider signal covering the entire bandwidth. And so, that's sort of the idea of, channel bonding, and you can imagine you can do this with aggregation as well. It's just that you're going to have gaps in between, plus 1 or minus 1 channels. Something else we do in 11AY is MIMO, and I mentioned that in the previous slide. And the type of thing that we are trying to do is being able to take advantage of things like either polarization, so that you can send some streams with one polarization, some other streams with different polarization, and therefore you get a better capacity. And you can get, in some cases, 10 dB or 15 dB isolation between them. Or simply, if you don't have polarization, it's just simply, trying to find true paths that you can basically do things like, 2x2 or 3x3 MIMO. There has been a lot of improvement to be able to do MIMO, to be able to do training, to be able to find these paths. There have been a lot of improvements on how the training is done. How do you sound the channel? So that you can actually find channels that have good properties, so they're not really correlated, so that you can really do MIMO. The next slide. These other approaches to do MIMO beamforming. Without getting into a whole lot of details, but there's a full protocol defined that you send these packets, and you can train forward and reverse links to get your MIMO channel, and then do beamforming on that channel. There is one very nice application which is called beamforming for symmetric links, and this is for scenarios where if you imagine a device like like a phone, for example, that's trying to connect with a base station or an access point, the access point of the base station, they're going to have a much larger array than the client device. In this device, maybe you're going to have 4 elements or element antennas. Where the base station could have, 64, 120. There are actually access points today that have 128 elements. So the gain on the access point is much higher. And so you could end up, depending on how you design your system, in a situation where the access point can reach the client, but the client may not be able to reach the access point if the access point is not really looking at the client. And especially on a Wi-Fi scenario where you have this random access, you don't know where your transmission is coming from, you're just trying to make sure that if anybody wants to talk to you, you're just listening to everyone. This could actually be a quite common scenario, where the access point is just listening, but it doesn't have any gain because it's trying to listen to a lot of stations, but the station cannot really reach the access point. However, if the access point were pointed towards the station, they could actually communicate with each other. And so there is a way to do beamforming to address this problem in 11AY, which is what we call asymmetric links, where you have this imbalance when you lose this antenna gain when you're trying to deal with multiple stations. Okay, and let me touch on this one here. I mentioned that there were different categories of beamforming in 11AY. Most of the ones that I've just mentioned, they in some cases they are looking for always the path that is the strongest, because that's probably the one that's going to give you better SNR. I wanted to spend a few seconds here on this first path beamforming, which is an application of 6 GHz that's not really looking at the strongest path. In this case, it's looking for the first one. And this is really to deal with positioning applications. So in this case here, let me just give you the example. Just imagine that you have a device here transmitting. Here you have the peer device. The example here is trying to show that this path here, this reflected path, will be the strongest one, okay, if you have some blockage in the middle. But actually, what we are interested here is not on this path. We are actually interested on this path here, because we actually want to measure range, how close you are from the other device. And that basically, you need a new metric to do the beamforming. So if you look at how the rays arrive at the device, this is how it looks like. So you would naturally pick the strongest one if you were to do the regular beamforming, but you really don't want to do that if your goal is not to find the strongest path, but really to find the one that's shortest distance-wise. So if I wanted to do applications like this device, what is the range between these and these? And you can imagine that some applications, if I'm getting close to a device, something happens. And if I'm moving away, for example, something else happens, depending on how close you are. It's a different way of doing beamforming. It's a different way. So, and therefore, I guess the field that I wanted, what I wanted for you to understand is that the standard is not really just suiting to one application, but there are ways to achieve different applications. This is one order, and there is also the backhaul application, which also has some different optimizations. So I spent some time talking about 11AY, and so far it looks great, and there's many new improvements. And so, but I really want to talk about where we are in terms of challenges. I really believe that in terms of millimeter wave in general, I don't think that the challenges that we face today are technical. I mean, 10 years ago, 12 years ago, there was really uncertainty about the technology, how the channel looks like, is it high power, is it going to burn the battery of your laptop, or it's only non-line of sight, by the way. I mean, I hear that almost every day. And I mean, believe me, from people that are, expert in, in many areas, technical people, they're saying it only works line of sight if you, line of sight, if you put it under a table or somewhere, it just doesn't work. I know I actually have to say that none of these are really technical challenges anymore. The products in the market, they show that they can work with no line of sight. Blockage is not an issue. Reflection works great. Power consumption. I mean, these devices are shipping in phones, so maybe they're not shipping in volume, and those are the other things that I want to talk about in the last three topics there. But power consumption, even power consumption, is not a major issue anymore. So I really don't think that the challenge is, again, from an industry perspective, I know there's a lot of challenges, technical, that folks are going to be looking, and that academia has a lot of improvements and things to look at, new applications, which I have on the next slide, some thoughts on that. But I don't think that the challenges are technical anymore when it comes to bringing this to market. I actually think that the challenges are really in this area right here, right? And a question is, 11AD has been there, the products in the market, why don't I have those in my hand? Why isn't it as available as something like Wi-Fi or cellular is in your phones? And it really comes down to cost, some killer application, and depending on device type, where do you place these devices in a small form factor? The cost, the price point for these technologies is not in the same level of price points that you can get. In the case that I'm talking about here, really Wi-Fi. It's getting there. It's much better than it was, 2 years ago. I can say that's much, much better. But that's still a barrier. I didn't put this in red. I put this in yellow, by the way, because it's shipping, but it's not in the volumes that we expect. The next one is the application. What are you going to use it for? In some cases, and really what I'm talking about here is applications for high volume. Because we do see this being used, in some applications. And I have to say, fixed wireless is something that has been a lot of talk about. Personally, I think it's a great application, but I don't think that's what's going to make it or break it for millimeter wave. I think it's just a starting point, but volumes there is not going to be what you really need to make this mainstream. And so the question really is, where is the volume? There are many companies and many folks looking at this. I have a personal view that this is only going to become high volume when it starts getting to phones and tablets and applications and devices like this, which then brings me to my third point. And my third point is, where do you place these antennas on a device? A device like this, if you open this up, it hardly has any room for anything else. So you really need when I say folks that build these devices, they really need to study and make sure that it really makes sense to put these radios on a device like this so that they have real usage for it, that customers are going to pay for it, and that there's going to be a return on investment. And that, to me, is why it's not proliferating at the rate that we all expected. So while from a technical area, from a technical field, the millimeter wave is great, and there's a great story around capacity and lower latency and all that, I think that the market is still challenged to be able to take these high volume. And I am someone that have been working on these for 12 years. So believe me, I've been waiting for a long time to see the high volume, but I haven't. So I guess the message I wanted to leave you here with is, it's a great area technically. I think it's the right thing. I actually, I say to a lot of people, it's the right thing for folks in academia, folks that are doing standards to work on. But we need to take a perspective on the market and try to work more, especially from an industry perspective, on how we can reduce the form factor to make sure that and come up with new applications that can take this technology to the mass market. All right, so this is my last slide, so I'm almost there. I wanted to leave you also with some thoughts around what is next, right? So we have 11AY that offers, data rates that are pretty high, exceeding 100 gigabits per second. It can offer latencies much lower than 1 millisecond. Absolutely can, just given the millimeter wave, properties. And I get asked the question, being involved in this area for quite a long time, what is next? What do I see standards evolving in this space? In my view, and I really haven't spent a huge amount of time thinking about these things, but I do imagine that if we were to continue working on the next generation of 11MY, who knows when, that we're gonna have to address things like new modulations, and here I just mentioned a few, right? There's a lot of work on FDMA, on single carrier FDMA, uplink multi-user MIMO. That's something that we don't do in 11AY yet. We just do downlink multi-user MIMO. There is a lot of work that we can do in terms of special use improvements, things like directional carrier sense and other things. And new applications. I understand that some of you have heard of these applications too. Those are applications that I think are quite interesting for millimeter wave. Not only consumer applications, but doing, radars, gesture detection. If you imagine a device like this and you're moving your finger with a millimeter wave, transmission, you can actually detect gestures and then do things on that basis. And then the whole topic of location positioning, which becomes actually the pretty good advantage of doing that in millimeter wave compared to lower frequencies. All right, so this is my conclusion slide. I think we have come a long way from a technical perspective. Again, being involved in this field for such a long time. And when we started at Intel, I started this project at Intel with one other person. And today there's so many people doing this. So it's great to see the evolution of the millimeter wave research and development in general. The market is adopting. It's just not that we're not out of the woods yet, right? So that's really just my perspective. And I think it's probably, I think a lot of people have the same view. If it was true that this was picking up quite aggressive with the market, we would all have millimeter wave in our hands today because those devices are there. And, and we continue to be interested. I don't want to leave you guys disappointed in any ways. I'm going to continue working on this technology. But I just wanted to also provide a balance so that we get a perspective from both sides, okay? All right, so that's all I have. I have some references here, things we have done in the past, so folks are interested, I'll share this with you later, okay? Thank you. Yeah, questions?
Thank you for a great presentation. So yeah, we definitely have time for some questions.
Thank you. This is really a great presentation. Couple of things I like to ask you. Regarding the EIRP limit of 40 dBm, it restricts the range where we don't have that limit in case of 3GPP, where we are going with 60, 62 dBm. So this, is there any effort to request FCC to increase the EIRP limit at 60 gigahertz? So that's the first question. And the second question, what are the main difference compared to NR, in your opinion, compared, other than the channel coding and stuff? But what is the main philosophical difference?
Okay, so regarding the first question, the answer is yes. There is work going on to, so I don't know if, I think everybody heard the question, right? So it's about increasing the power ERP for, with the FCC. There is work going on, there's coexistence analysis being done, and that work is ongoing. So I guess what I can say is, you know, we've been working with other interested parties to request the FCC to increase, to remove some of the restrictions around. The FCC has this notion that you can go to higher power, but only if you use things like horn antennas. It cannot be phased arrays. And so we are trying to, you know, show them that, you know, this restriction doesn't have to be there, especially if you're talking about these backhaul point-to-point links. So there is work ongoing there to address that. Now, to your second question, what is the main philosophical difference between what we are doing in I guess, in IEEE and 3GPP? I think, you know, the main difference comes from the fact that in 3GPP they are looking at, I don't think there's a whole lot of philosophical difference. To me, the differences are more technical in nature. They deal with a more scheduled system than we do, and therefore they can do the things different. But you know, looking at the 3GPP, for example, the way to do beamforming is very similar to the way to do beamforming. They have this notion of, you know, sectors, and they have different names for it, but sectors and refinements and all these things. I actually think in one of the bullets that I have on this slide, that I do believe that IEEE and 3GPP should, and they could, collaborate more in this space. I can speak, at least for my own company, I don't see that happening, but I can speak for my own company where we discuss this a lot with our 3GPP folks, to make sure that there's a good understanding of where things are going on our side and vice versa. So I guess the response to your question is, I don't think there's a lot of philosophical difference. It's just that the approach that we take and they take, because the use cases are different and the applications are different in many cases, will lead to different technical solutions.
So one follow-up on that, and then I'll let Amitava hog the microphone a little more. Technical differences, that's interesting. But, you know, say UE applications. I'm just saying when the first UEs come to market, hopefully, I would think that both the AY and NR standards would want to be implemented, and hopefully they are common enough so that it's easy to do, rather than having two different components. Or what do you think? How do you think it's going to be implemented?
So I think NR is, you know, right now, at least from our guys internally, okay, you know, NR right now is really worried about 28 and 39 license bands right now. Okay, so, you know, I see that in the areas where this will be really relevant is if they were to come to the license, which they want, by the way, which I think it's fine. That is the area where I think, you know, we can explore more commonality, for example, using similar waveforms, you know, and basically be able to reuse IP blocks, right? But since right now they are more concerned with 28 and 39, I think that most of the reuse is going to be on the antenna side. You know, on the antenna, I think there's a lot of possibilities for reusing some of it. But I think on the digital side, I don't see much. Perspective.
So one of the major things, correct me if I am wrong, is that the main modulation scheme which are productized is single carrier, right? Although it has two options, both
For-
OFDM and
For IEEE.
IEEE.
Yes, yeah, absolutely, yes.
Yeah, and whereas in 3GPP it is OFDM and single carrier is an optional uplink case. So the question is, and this is in line with what Nokia thinks, is that for bands above 40 or 50 gigahertz, single carrier is the way to go. And do you agree with that assessment?
I very much so agree.
Yeah.
And we have data to show, and if you go to those bands, and there is case to be made that even in 39, single carrier could be better than FDM, but that's the blurry area. So I can understand why you're coming from that perspective. But when you go above 40, 45, a single carrier is going to outperform FDM, absolutely, especially from a power point of view.
Any other questions? Go ahead.
Thank you for the great presentation. I have a question about any future coexistence between the .11 AY and other commercial systems at the unlicensed band, the higher gigahertz frequencies. Now, as far as you know, like LTE Wi-Fi coexistence is going to take place over the 5 gigahertz. Now, do you take this into the design of the system at these frequencies as well?
Okay, so let's see, because I think the speakers are pointed towards another direction. So I guess the question is, yeah, I'll try to repeat, and you tell me, if I understood what you said. Your question is around coexistence.
Exactly.
And the question is, well, we have coexistence in the unlicensed bands, in the lower frequency bands in 2.4 and 5 gigahertz. Whether this is something that we also are doing for 60?
Yeah, absolutely.
Okay. Yes, absolutely. I mean, that's a major requirement. So without that coexistence requirement, I don't know if you know, but in many regulatory domains, in Europe, for example, it's in the regulation that the unlicensed technologies, they have to have some means of coexistence. And most of the cases, it's some means of LBT, listen before talk. So for your device to sell into the European market, for example, if it's operating a Wi-Fi device, it has to do listen before talk. That same regulation applies to 6 gigahertz, applies to millimeter wave, unlicensed bands. So the standard has to be able to have means of listen before talk so that it can defer to others. So that's one level of coexistence. Now, there is another level of coexistence, which is backwards compatibility with things that were developed already in the IEEE, in this case of 11AD. And that was what I tried to show when I showed this picture. But this is like coexisting with yourself, because you're coexisting with your legacy devices, so it's a little bit different. Is that clear?
Yeah, thank you.
Yeah, thank you.
So, any other questions? Oh, Dave.
So when you guys defined all these MIMO stuff in the standards and 275 gigabit per second, all that kind of stuff, did you guys do back up the envelope calculations on what kind of, how this thing would be realized, how much power consumption would there be, et cetera? How realizable these things that you're putting in the standard are?
Right. The answer to that question is yes. So before we actually embark on a development process of the standard, there is a period of time before that where, and that's similar to 3GPP, it's not unique to us, where there's a lot of channel measurement that happen. Number one, to just show that you can actually get multiple channels between two devices. So that's number one. And then there is work there's a lot of simulation work to show that based on that you can actually from a technical side, from a technical perspective, be able to realize a MIMO channel on those frequencies? So the answer to that is yes. Now, there's a second side of, a second part of it, which is how can you realize in practice in a device like this? The answer to that question is also yes. And I can give you actually an example which is real. Intel, and that's available public, so I can say, Intel ships laptops with 6 gigahertz today, and those laptops, they actually have 2 antennas. And the reason for that is because we are using them today as diversity. We want to make sure that regardless of where you are, because the user can do this, can move, right, doesn't really matter. We want to make sure that if you lose the link from one antenna, you can get from the other. Now, we are using those for diversity, but there's nothing that precludes us from using them for MIMO. So, so yes, I guess the answer to the question is yes, and we have devices today that could be using MIMO.
I was thinking more about the receiver implementations and what kind of hardware would actually manage to take 8 MIMO streams and demultiplex them and all that kind of stuff, right?
Right. So I don't see, okay, so that's a great question. I don't see, there's one thing we do in standards, and I guess to your question, right? I don't see 8 special streams being something realistic in these frequencies. I think it's going to be, I would say even possible, just looking at the channel to get 8 special streams. However, 2x2 MIMO, and in some cases 4x4, I think it's very, very much possible. So.
Okay. Any other questions? Maybe. So, yeah. So I had a follow-up question. One, actually two. One, you mentioned, EIRP. I think FCC would agree, but I think you would agree right now that when we measure, many of the people, when they measure the beam patterns, they're all over the place. So there is a lot of leakage. So first, the devices have to get more accurate so that we're not burning holes in people or something. And two, so did I understand your last comment correctly that we cannot scale in terms of processing? Because, I asked this digital processing stuff that, can we process 8? And some people say, oh, yeah, that's not an issue. We can do it. So did I hear you correctly that not too many? Because there will be channels where you can have 8 streams you can support. So following up on Mara's question, do you think that's feasible? Maybe not on the UE side. Or is there a limitation there? And access points, I'm hoping for sure.
Right. When I respond to your question, to the question there, I was really thinking of single user, right? There's definitely a case to be made, that you can do multi-use, downlink multi-use, and that's why we have 8 special streams, but with downlink multi-use on MIMO, where you could be doing 2 streams for one, 2 streams for the other, 2 streams for the other client. Again, for single user, I don't see it. That's my comment. But for downlink multi-user, I can actually see access points doing that.
Well, thank you very much for a very interesting presentation. So let's thank the speaker again.
Thank you.
Okay. So now I guess we should have the readout leads for the breakout sessions from yesterday come up to the stage and kind of give us short and sweet. We are running a little bit behind. I would say at most 10 minutes, what are the big points that discussions came up in your breakout discussions, and with the aim to prime the second panel discussion that'll follow. And some of the things from Carlos's presentation would go into that as well. So come on up. So who is for the hardware and signal processing lead? And signal processing and networking. Who's going to present? And the standards. There you go. So which one is this? So that was describing, no, the leads can give the, I will need that, you need to email these to me.
Oh, I thought you wanted.
No, the leads would present, so, okay. You can use laptop if you want, but 10 minutes. Okay. So, okay. So you're going to be the...
I prefer to be later. My laptop is showing on kind of, I need to connect to my USB.
Okay, so you're the three people? Okay, let's start. Okay, we need one person to do that.
Oh, sorry. Do I do panel or not?
Oh, panel? You can, yeah, you can do a panel too, sure. Okay, hurry up, man. Okay, why don't you start, Daniel? While we're doing it, we also need a volunteer scribe for panel 2 discussions. Somebody's got to be here. Come on. Arjuna, thank you very much. I could take one more too if somebody's willing. All right.
Okay, now I have it. So I'm summarizing our discussion on the. Okay, sorry. Yeah. No. Okay, no problem. So I'm gonna summarize our discussion on the millimeter wave standards, especially this 5G new radio. Okay. Okay, I'm trying to getting a little bit closer. So. Yeah, our discussion on 5G new radio and WiGig and 802.11 AD and AY. The structure of this, again, there was, we started with an introduction, then we had this open discussion with some prepared questions and a wrap-up at the end. The discussion leaders were Kemal Haider from Rice University, it was me, Daniel Steinmetzer from TU Darmstadt in Germany, and Sarah Jost from National Instruments. The first big point in our discussion was, kind of a general discussion, and that we first wrapped up the last 6 years that we had with 11 AD, and what can we learn with that for launching AY and 5G now. So we first started this discussion with looking for the killer applications. And we discussed a lot about the docking scenario that exists for quite some time in 811 AD. But this was not really one of those killer applications, as we consider it as, if you do the docking, you still need a kind of a power connector that make you not really work completely wireless. The other application that exists in this scenario is video streaming that exists already prior to 11 AD, but why do we really need this as a killer application, as we still can stream a 4K video with with other wireless technologies. The other big application that we came about was virtual reality, but even in that we don't see that this is ready to reach the mass market. And the same applies to other applications in data centers and smart factories, where millimeter waves might be used well, but it's not really this really forward-driving killer application. So instead of, we just identified one of the big enablers that came up with for millimeter wave technology. One of this is the spatial reuse, and to provide this high throughput even in dense deployment where we can use those data weights to serve multiple users. And for that, we came up with a suggestion that for the upcoming standard, we should provide not only prototypes that show this high throughput, but also show that this high throughput is available in dense deployments with a lot of users. And from that, we moved to another discussion point, which was machine learning. And we agreed that conjunction with machine learning, we can improve our protocols quite a lot. For example, we can learn patterns from the beam steering, and we can find optimal antenna alignment, especially in case when we apply hybrid beamforming technologies. And with that, we move to the question, how can we influence the standards from the academia perspective? And there we find that this is easier in this is easier in 11 AED and AY than in 5G, especially if you have collaborations with industry partners. But still, anyway, we should try our best to put our ideas we have on millimeter waves into this new developing standards. The second big point we had on our agenda was beam training. And here we see that a lot of work is going on. And we agree with what Carlos presented before, that we should keep the beam training open and adaptive to different scenarios. As we see it in devices with 11 AD right now, this beam training is rather fixed. We have this fixed beam and we try to cover all directions. But later on, this might not be useful to even and we need to be adapted to different scenarios where we might be more effective by keeping this adaptive. And then the last big point we discussed was the channel models. And in that we discussed a lot what channel models are currently available and what we need those channel models for. And we came to this conclusion that there is no one single channel model that can capture every aspect that we want to use this channel model for. So we need those different layers of abstraction for different purposes, and we need different channel models for that. And but our main concern is here is that a lot of people are doing channel sounding right now, and we need to find an easy and accessible way to access those data that came up from those measurements to design those channel models and make different protocols in millimeter wave technology based or work with those channel models. And with that, I guess I covered all of the important aspects that we've covered in our discussion. And I would like to hand over to the next speaker.
Thank you, Daniel. I think regarding channel models for different scenarios, I think for 3GPP studies, they have characterized many different scenarios like urban micro and, rural macro and indoor, and they are being studied. And 5G Channel Modeling Alliance, there's a lot of work going on there too. So,
but with that, we do not want to only focus on those different environments where we need those channel models. There are channel models that are used to drive the hardware manufacturing to test those hardware. There are channel models to really cover those different environments, and there are also different channel models to predict large deployments. For example, if you want to find out where it's best to put in access point, you need a different channel models than when you want to define or
that's
to create a hardware.
And the first two kind of exist, but the third one is where nobody has any clue, really, I think. Even though, 3GPP thinks they've done all the channel modeling. Oh, yeah, after the breakouts we can mention. Oh, Yes. Good point. Okay. HDMI is connected.
Let me just read it out. I think it's having an issue.
It was connected. Maybe it'll come alive. Don't disconnect it. Just read it out. Okay. And hopefully. So put the VGA as well, because right now it may be VGA.
I see. Okay, let me read through. So in the hardware CSP breakout session, we had around 14 attendees. We gave around 70 minutes of discussion with around 40 minutes for open discussion. And we had like 3 panelists, which included Greg Chance from Intel, Kate Remley from NIST, and we have scribes Vishal and Arjuna. So the audience were first introduced to the session, its objectives by the organizers, essentially on the challenges of the hardware CSP interface, alternative beamforming approaches, advanced beam management, machine learning, and physical layer security. So after this introduction, we had a discussion on the mobile handsets, which was led by Greg Chance from Intel. I think it's there now. It's working.
All right,
okay.
Good.
Yeah, thanks. So I think some of the emphasis was again on the placement of the antenna on the mobile handset and how does the millimeter wave constrains this placement. So the distributed antenna array placed at the edge of the mobile device, it needs to connect to, let's say, a single microprocessor at the center of the device or somewhere else. And so there is a long route from the edge of the antenna to that microprocessor. So there were considerations or the discussion about what will be an efficient way to orient these patch antennas, also to reduce the blockage. So the viewpoint was that it needs at least around 4 arrays to cover both the directions. There was also discussion on optimal silicon partitioning at the system level, which can support like a high-speed input-output. So what it means is essentially how do you partition the RF, the IF, and the baseband and the microprocessor, and what will be an optimal scheme to do a functional partitioning. So regarding to multi-user MIMO, there was a discussion on what are the hardware challenges, and some of the challenges here are like if you have multiple PAs, then what are the different, how can you use like a digital pre-distortion schemes so that the EVM can be tailored for multiple PAs for multi-user systems. Similarly, like if you have phase noise issues, what are the phase noise cancellation approaches that can be applied here? So I'll go to the second point, which was led by Kate. So she basically introduced to the millimeter wave test beds and the RF measurements that the test beds that are being done at NIST. And then how are these test beds that can be used for hardware calibration with emphasis on like phase, impedance, and power calibration of the signal sources. And there were discussions on that there is a need to better understand the usage scenarios and allow measurements or standardization procedures for that. The third point, I think, which kind of took a lot of energy here was about the benchmarks and deployment scenarios that are needed for the hardware CSP interface. So one realization in the discussion was that there are metrics that are existing for hardware, there are metrics that are existing for CSP, the signal processing side, but at the interfaces, what are the most optimal 5 or 6 metrics that would differentiate different architectures? So the emphasis was on spectral efficiency, and then there was also a follow-up point regarding the discussion between academia and industry. And some of these metrics that are driven by the industry are product-driven and contains proprietary numbers. So industry benchmark is a good idea, but it never materializes. So academia should lead with its own figure of merit as well at times. So I think as some of the previous speakers also mentioned, we can follow these benchmarks through the IMT 2020 submission and the RAN4 for different PA efficiency. And then the last 2 points were the discussion about what are the next problems. So some of the things were focused on energy efficiency and spectrum efficiency. So we need to identify where the major improvements are, like in the ADC speeds, the number of antennas, for example, the power amplifier efficiency that can support like not only single user but multi-user MIMOs, and emphasis on phase noise and carrier recovery schemes. So I think these are some of the concluding remarks, the last, which was given by each of the attendees, and then I think I just kind of summarized it here. So we need to add, one observation is we need to add more focus to millimeter wave applications in hardware apart from 5G. So I think a lot of focus yesterday was on 5G. Another point was on enhancing the spectrum efficiency at millimeter wave. And what are the different schemes to do that? So why don't we go for higher frequencies and higher bandwidths and higher throughputs? That's one area. Another area is full duplex. So a comment on that was that full duplex is more promising for backhaul applications. The next one was the higher order modulation schemes. So higher order modulations, I mean, maybe it may be a feasibility for backhaul, but for very high order modulation schemes will incur phase noise penalty and so or phase noise requirements. So it may not be promising. That was one of the observations. Then another comment was on using millimeter wave techniques for higher analog precision, and that we can also use wireless backhaul as opposed to just a fiber backbone. So the idea here was that what are the metrics to use for fiber to millimeter wave last mile connectivity, where the wireless backhaul to homes was suggested. And so in the end, the concluding remarks on this was that we can also have like a need for phased array metrics and benchmarking, which can capture like different number of beams, different use cases, and dramatically different solutions for, again, different resolutions. So I think that's one of the next agenda that we will be following up with. So, okay.
Thanks, Subhanshu. Okay. Marco, okay, thanks.
Thanks. See if this connector works for you.
Yeah, we cannot connect that. This here. Yeah. Okay. Does this work? Yes. All right. Okay, so the session started with a presentation from Tom Henderson, University of Washington, who's one of the fathers of NS3, Network Simulator NS3. Tom set the stage for a discussion around the millimeter wave module that was developed at NYU, and that we believe can represent the reference point for a wider discussion about networking and physical layer in millimeter wave research. Then I joined with a little bit of delay, and I talked about our recent beam scanning implementation based on the mid-December release of 3GPP number 15. And during this discussion, we brought up a set of questions. So, most importantly, is the current error model, which is based on LTE, applicable for millimeter wave? If not, how could we go about developing a new and different one? How important are blocking and antenna patterns? Traditionally, we model obstacles as creating a 30 dB loss, but for example, a recent Qualcomm paper suggested that the median is actually closer to 15 dB. Are there more inputs and comments? Can simpler statistical channel and error models be developed, such as finite state Markov channel? And then about fast fading MIMO channel models. They are computationally very intensive at runtime. So we currently use approaches that are based on offline computation. Is this valid? And finally, we are asking ourselves and trying to find ways to parallelize or otherwise optimize 5G wireless NS3 simulations for faster runtimes. So these are a set of questions that were brought up during this first part of the discussion. And as I will mention in the end and stress its importance, we'll bring all this discussion, we'll push it forward offline by creating a mailing list. But I will tell you more at the end of this presentation. And finally, we announced the creation of an app store that is a placeholder for NS3 millimeter wave and other projects. And also, I announced that Nokia may add their own code improvements related to millimeter wave NS3. And finally, NIST also has worked on some improvements of the code by integrating ray tracing in millimeter wave. So all this hopefully will be talked in even bigger details in the next RCN session. And then Ismail from North Carolina State University talked about the role of ray tracing for studying millimeter wave propagation. And he brought up questions like, how should we model small reflectors at millimeter wave bands? How to accurately capture real-world propagation behavior with simulations? How many multipath components are good enough? How to capture line-of-sight and non-line-of-sight propagation effectively? How to model correlations across bands? And how to model user mobility and orientation for directional transmission and reception. So all these questions also will be shared in this mailing list and some repositories that I will tell you at the end of this readout. And finally, Nicola Micoliusi from Purdue University talked about the importance of studying trade-offs between sensing, tracking, and communications in millimeter wave. And he proposes to use tools like software-defined networks, machine learning, and cloud computing. So there's space for a lot of interesting research here. Again, this will go in the shared placeholder that we will work on in the next few days and share with all of you. And this brings me to the last part of this readout, which is, here I just wrap up the discussion points. You can take some time offline to take a look at these and see, particularly if you're interested. Because if you see something where you feel like you can say something, you can add some comments, ask some questions, or bring some criticisms, that's exactly the right, this is the right place to do it, because we plan to create a mailing list with announcements about code extensions or papers related to these topics, so in the intersection between PHY and networking, a placeholder for questions, and then we will build and share a repository with shared documents, papers, ideas, and a space for comments. So we'll have a document, a doc that can be shared where we can all together, add items, research items, or for particular research items that are already mentioned in the document, we can add comments or, again, critiques. And finally, now more than ever, we believe that we should aim at co-writing a white paper, or maybe even more than that, a paper, find the proper venue, which will basically be the result of this offline discussion, where, very importantly, what I personally would like to see is that we're able to prioritize the research items and see, okay, this is extremely important in intersection PHY networking. This is less important, and then based on that, we can focus and beamform more optimally. And to conclude, just an example, thanks to yesterday's discussion and the poster session, I was able to gain some really interesting new ideas related to this interface PHY net. And that's exactly the goal of this workshop. And this will be the placeholder to bring to avoid letting all these ideas just float in the air and then go nowhere. Instead, write them down and maybe also transform that into research publications or code improvements and so on and so forth. So that's pretty much all. Thank you.
Somebody who used the Mac, right? Huh? Somebody was using a Mac.
Oh, I hope try it, but do you have an HDMI? You have an mini display port to VGI? Yeah. Okay, so let's. Right. Doesn't seem to be. Huh? So, do you need to press something here? Yeah. No, you have to put it onto the, it should be something like this or something.
Yeah, that's what I will do. Okay, I guess let's switch to Windows. So let me just introduce. Why don't you go and just introduce?
Okay, well. All right, well, while Marwan is fixing, ready to throw his Mac in the trash, let's get the panel 2 panelists up on the stage. So Amizawa, Ghosh, you need to panel 2, and then Madhav and Carlos, please come on and have a seat here so that you know, I think this projector is going to shine its light straight into your eyes. Let's see, Sarah. And Ali Niknya, unfortunately, couldn't come because of some last-minute changes. So,
Can I
yeah.
use your laptop?
No.
Or somebody, Windows laptop.
Yeah.
Well, I need, I guess, some laptop where to just copy this. Just
Okay, yeah, copy this.
even yours.
No, so this is on, it's connecting video. You have, give me that. So what is your slide that you want?
Let's see, RC. RC. This one.
Okay. Oops, wrong one. What the hell is going on? No? Man, you don't. No, that was the extent, so I can't. Selector only. What this? Why isn't it? Okay, good. Well, now I can't see this. This is great. Oh, there we go. I don't know what's going on. Wait. Oh, finally. Thank goodness. Okay. There we go.
All right, I guess we can start. So this is our second panel for this workshop, and it's focused on industry-academia collaboration on moonshot millimeter wave contributions. We had kind of a similar panel in the second workshop at the University of Wisconsin, and we'd like to kind of follow up on some of the lessons learned and outcomes since that panel. Let me just focus on two fundamental goals for the panel. One is to actually identify what are really the big impact problems that we can collaborate on as an RCN community with a target for the next 3 to 5 years. We've listened to various discussions, readouts, keynotes. Based on these discussions and presentations, what do we think would be really something that is worthwhile to pursue jointly with, between academia, industry, and national labs? And I also added another thing is, what are the obstacles that you see or challenges for achieving such collaboration? We always talk about collaboration. Everybody has the right intention to do it. What are the issues that you see in your mind that is really, making this more difficult to achieve? I do have some additional follow-up questions that you guys have not seen, but I will wait until, we at least respond to these fundamental issues. Now, just as a reminder, from some of you who have not attended last RCN, some of the outcomes that came from a similar panel is, looking at some big impact problems are listed here. And this is not by no means an exhaustive list, but these are, some of the issues that people felt are worth pursuing jointly between academia and industry. Examples, exploring higher frequencies, beyond 100 gigahertz, looking into achieving sustained rather than peak performance, particularly important for, streaming applications and the like. What are the economic considerations that people have to look into in order to kind of deploy and look into new technologies? Various performance trade-offs, bandwidth, latency, energy, etc. Many felt last July that these are important issues that this community should be looking into. So we have a set of distinguished panelists. And Akbar already introduced, we have, I guess Ali is not present here, but we have 4 panelists. We've already listened from Carlos, our keynote for the day. Dr. Amitava Ghosh was our keynote yesterday and was introduced. Dr. Meadow is here also and present from UC Santa Barbara. And Dr. Sarah Yost from NI, who also presented yesterday. The format that we'll have is each panelist will have 3 to 5 minutes. You can use slides, or if you'd like just to talk without slides, that's fine. And after that, we will open the floor for questions and answers. I have also my set of questions, and the audience can participate as well. So without any further ado, maybe we could start. I don't know who wants to start. Now, these are the easy questions. The difficult questions will come later. So, it's not working.
All right, trading mics. Good sign that no one wants to start. So talking about just, I guess, handling the first one is looking for areas for industry and academia to collaborate. One of the things that came up yesterday was kind of how do we take, there's a lot of similar challenges that are being looked at for the 802.11 community and in the more cellular-focused community. I think one of the important things that we need to work on is sharing between both industry and academia so that we don't solve the same problem twice, and more importantly, so that we don't solve the same problem twice in 2 different ways. Chip real estate is going to be very, very important on UEs and devices going forward. And so for anything that we can, where we can have similar reuse between Wi-Fi and cellular, I think it'll be very advantageous for as we try to commercialize these technologies, especially in millimeter wave. And there are just also some interesting conversations going around standardization processes. The 802.11 community is very academia friendly, but on the industry side, it's very much driven by commercial. And so having, just being open to the ideas that are coming from academia and maybe having a better channel to explore some of those ideas and have academia influence the industry for some of the innovative solutions to solving these challenges is going to be important. So that way, like I said, we can work on taking the problems and solving them in one way collaboratively instead of solving them 2 ways.
Great, thank you. All right, so from my perspective, I'm a firm believer in greater collaboration between industry and academia. And as a matter of fact, for the last several years, I've actually been funding universities on specifically the topic of millimeter wave. That's something I've been doing for the last 3 years, and I'm continue doing that this year again and going forward. So absolutely, I think it's something that in general, the industry should be doing more together with academia. I think what we need to do better, in my perspective, is that I think there is a lot of, it almost feels like the academia doesn't know much about happening in the industry and vice versa. I think we need to find a forum or a place or somehow, for example, in my case, in these interactions with the university, I actually spent time going there and giving talks to the university students to actually tell them what's happening in standards. Many cases, I do that, 3 times a year. I provide an update, a dump, and say, hey, this is what we are doing, this is where we are going. By the way, here are the links to all the contributions. Students are able to get, source codes for the channel models that are being developed in the standards. They're able to contribute. So I think there is a real opportunity there as long as there is a will on both sides to exchange this information. I do that on a, with one particular group, but I believe if there was a forum that this could be done more broadly, that many people from academia could actually, and people from industry, they could volunteer to come and, speak. And that exchange could then happen. And likewise, industry needs the fresh new ideas, the fresh blood from academia. And whenever we're looking at the next standard, the next technology, I was actually mentioning that to Monisha before, it almost feels like, some in the industry always want, oh, let's just double the bandwidth, right? Just, increase channels, okay, we get higher data rates, and that's good. I think that, we are missing the point of, that interaction with academia, what are the new ideas that you've been exploring. That usually gets fed into industry through students that come, but I don't think that's good enough. Again, if there was that forum for exchange, I don't know how to make that real, but I think it would be beneficial for both the industry and academia.
Yeah, so as the only academic on the panel, first let me address this issue of obstacles and challenges first. So I guess I really think that the ideal academic research should be pre-competitive and looking sort of relatively far ahead. I've already said that yesterday. It should be sort of free from IP issues in some sense, openly published and such like. So in some sense, it's much better matched to a model where industry basically just sort of identifies, okay, here are people that are doing interesting work, and tell them they're on the right track, give them, some connections, but not really get entangled in the IP issues. That's often a big hurdle when industry wants to fund somebody, right? So that's and by the time you get to a point where you want to fund something very specific that is actually has an impact on the technology, the research is then already successful, right? That's almost like you're trying to do tech transfer, and then it's sort of being done at the university potentially, but it's not, it's perhaps too, it could also have been, if it were mature enough, it could have been done in industry or via startups. It's just grad students are cheaper, right? That's sort of how it often works for the stuff where we get entangled in IP. So I think really the idea of much more gifts and equipment donations and no strings attached long-term research should be a good model. And then, like you said, if it doesn't, in addition to the, so you guys in standards have this web page where you have all the contributions and all that stuff going on. If there were a web page actually for millimeter wave academic industry collaboration where people are posting the most recent results, sort of like an archive for millimeter wave, and where we keep exchanging ideas, that could be a good start in addition to the physical presence, right, that you were talking about. So I don't know who would run it, but if it's important enough, that would be a good thing to do. Maybe NSF can run it.
Well, that's what RCN this RCN already has a website, and this could lead into it with the industry collaboration. So, excellent points. So, Amitawa, are you done?
So, can I just, if I may interject, I see lots of focus on the challenges, which is great, but if you guys can also address what are the, big impact projects and problems that this community can also look at.
So from Nokia's viewpoint, Nokia funds and works with universities across the world, hundreds of universities in Europe, in Asia, in USA, and we fund a lot of industries to do research in various aspects. And so that is from a, so I don't understand, so you want a university industry combined collaboration, or each company is doing their best to sponsor each universities? That's what we are doing. Like in Europe, you see there are these European projects where the universities and industries are working closely together for the European projects. In USA, there is not such, there is this DARPA and other funding. Those are the vehicles in USA. But the other thing, what I realized, for some universities, we have to pay the hefty affiliates fee, 100K or something. And my experience is that we don't get much out of it by paying that 100K, you see. We get some research, but from my viewpoint, what we do is that we sponsor universities, they do the work, we guide them, we tell them what are the latest state of art and how you can improve them. Then we hire summer interns who work with us for 2 months or 3 months, and then they do publications and IPR in our premises, and then we hire those summer interns. That is the best vehicle of university industry collaboration we have. This affiliate membership model, I don't know, how does this work? So that is with respect to the management. With respect to what we are doing in the universities, there are a lot of new projects we are doing. Just I mentioned yesterday, looking at frequencies beyond 100 gigahertz. So the first step is to go and measure the channel. So we have taken the step, and Ted is an expert in this area, and we are doing that with him. We also have RFIC project with various universities, you see. So can we do a wideband RFIC at millimeter wave band from 20 gigahertz to 100 gigahertz? What are the challenges of doing more number of elements in an antenna? Like 1024, you go to higher frequencies. So these are the work which should be done. But also what we do with some of our universities, they provide the theoretical basis. So we do a lot of simulation in the industry, but the mathematical modeling on the bounds and upper and lower bounds, that needs to be done. And we do this work with universities, like for cell backhauling. We have done a lot of simulation on the advantage of, say, integrated access and backhaul. But we asked one of our partner university to figure out what are the theoretical limits and how to model this one. So that's where they provide us a lot of benefits. So 3 things: we collaborate with industries across the world, universities, and then we have specific projects with them. In Europe especially, we work together with the universities on European project. In USA, we also hire summer interns so that they can gain industry experience. Then we hire those summer interns for permanent position. So I think we have a very healthy relationship with industry, but a centralized format of all universities and all industry participating, there should be a leadership option on how to do that, and that I think is very challenging.
I just wanted to talk about some of the opportunities. One thing that, so this actually has been brought up already with the 3GPP and the Wi-Fi or Wi-Gig community sort of proceeding in parallel tracks. I could certainly imagine systems in which you are basically seamlessly using unlicensed spectrum throughout, indoor and outdoor, and even with the 40 dBm restriction, the sweet spot for millimeter wave is really these relatively short-range links. So I think having base stations / access points all over the place and giving seamless coverage could be a very interesting thing to think about. And then I guess that would require, well, we don't really have to worry about standards in academia, but I think one can actually at least explore the feasibility and see how you would have protocols that work seamlessly. The other thing that is a big area, which is not necessarily just communication, is you guys have already talked about it last year, autonomous vehicles. I mean, there the current state of the art, which is being pushed by everybody, Waymo, etc. I mean, really, they're heavily based on these lidar as a sensor and these so-called high-definition maps. And it's really hard to actually create and maintain these high-definition maps. LiDAR as a sensor is good, but creating this high... So I could certainly imagine millimeter wave and vision and things like that as being providing a self-contained system that doesn't have anything to do with, that doesn't require HT maps at all, for example. So, I mean, there's the other thing that sort of worries me, and again, this is something that the current state, I guess that's one strength of the Waymo type design is that they don't rely much on GPS at all. And that's good because GPS can be jammed so easily. So once you have self-driving cars moving around, you basically have, you can have really bad things happening if they rely too heavily on GPS, right? So one can easily imagine some sort of picocellular architecture based on millimeter wave that's also doubling as a very strong kind of GPS replacement, right? That kind of stuff. So generally the sensing part is interesting both from the point of view of this localized sensing around you and from the point of view of infrastructure that provides sensing and localization. So.
Okay, so I'm going to interject one thing from a NSF perspective. So when I went there, and one of the things that and this is my personal view, that I don't think we are fully innovating in terms of, our collaboration could be much better. Maybe that's very idealistic, but we as a country, I don't think are fully innovating in terms of, industry and academia working together. Notwithstanding all the great relationships that Nokia has. And, thank you for saying that, hey, we don't really get much of the affiliate fees, except that you guys get the first dibs to their data or whatever. But the students are the big thing, right? So I think there's a training angle too here, which could be part of this. And then I think it could be something multi-tiered, where there could be something, a general repository. This is a area which, regardless of what we say, there's a lot of hiccups left, but I think there's still a lot of improvements in technology that could go on. And I think there'll be higher frequencies. This, to me, is the tip of the iceberg in some ways. So this is a longer-term aspect, the way I'm seeing it. So it could be multi-tiered. There could be, we create a model which is under the millimeter wave umbrella, which also ties in with what power platforms are trying to do. And we will have those test beds, city-scale test beds available to leverage as well in the coming years. And so there's a common base which is very open, and then there could be more directed ones where you kind of have IP constraints coming in and your special projects. But I think this will require thinking out of the box. That, hey, how can we help? What information we can share? And then thinking about, all of you are busy. Industry folks are even busier because they have the bottom line in front of them. So what are things which you'd like to see done 5 years, 10 years from now? And that's where the academicians could help you. And I think not all academics would be able to do this, but I think we're looking for people who are. So there'll be a sieve as well. So this RCN could serve as that umbrella organization.
So if I may just add to what Akbar said, and this is kind of one of the issues that I also was thinking about from a company's perspective. I mean, you mentioned that, the return that you have in terms of the funding provided to universities may not be as great as you may expect. And I'm just thinking here, are these related to IP issues, confidentiality issues that, from an academic perspective, maybe we are not really sufficiently exposed to your needs, and because of these concerns that we end up really kind of working on something that is not exactly in line with your objectives.
So as I said yesterday, say imagine Nokia, we are in the business of making profit, right? And we have some strategic direction, and we know So the technologists have some idea that where we want to go. And we work with universities closely on an NDA basis to share our ideas to see whether they can work with that. So why we will share our strategy and strategic direction with the world? You say that is not the way it will work. It will work with one-to-one, with the various expertise in the industry, and that's how it is done, right? So we work closely with the universities who have certain expertise. We give them a problem, they solve it.
Okay, so Amitabh, I've heard this. So if you have, you seem like Nokia is doing the best it can, and it can't do any better. So if that's the case, there's nothing for you to contribute to this panel right now. I think the key is to kind of say, hey, what else can you do better? If you think that you are doing the best as you can, then I think that's very myopic. I'm sorry.
No, there are some improvements which have happened.
Let's think out. So let's
just hold on, Akbar.
Bottle of wine or something in him or something. I don't know.
But there is this European projects where the universities and industry work together. Now, if you go to the 3GPP meetings, there are...
Mike, a little higher.
In the 3GPP meetings, there are a lot of universities who are contributing, like TU Dresden and some universities. Even NYU was in the channel modeling meeting initially. So the trend is changing where the university and industry are working together. But if you sort of, and that I think is an improvement over the past.
Frankly, I mean, I'm perfectly okay with Nokia pursuing its strategic direction, because I would rather come up with my own strategic direction, as an academic, which is looking further ahead than them, right? So I think that's just fine. But I think if you had some, it's almost like if you had some, if RCN could become something like this repository of ideas, and there was enough interesting stuff happening, I think it would just build on itself, and it would, it would attract people, right? I mean, that's how it has to be, because the kind of stuff Amitabh was talking about is still relatively, I think, short term, right? I mean, basically, well, I guess the beyond 100 gigahertz might take 5 years, but it's still, they have something defined. And so that becomes less interesting anyway as an academic, right? If they already have their path defined, why should I care?
Yeah.
Right? It's also that, right?
So I think one of the things that I'm hearing from, so I agree with that, and that's fine too, that, that we have a strategic vision. I'm not saying that you share your strategic vision with us, but to say that there aren't aspects that, could be looked at by the brains outside of your institution or your immediate partners on a longer term basis is, I think, myopic. So not to even entertain that idea is kind of silly. Now, whether you can sell it to your organization, that's a different thing, but I am challenging you to think outside that box. So let's give the mic to Carlos. Amitabh, Carlos, I want to hear from Carlos.
Can I step in for a little minute before we get to Carlos?
Yeah.
So again, I mean, I have been on all three sides of this pyramid. I've been in industry, I've been in university, and now I'm at NSF. And I think there is kind of a disconnect as to what the two communities think of in terms of how they view collaboration. So for an industry, and I've been in industry and I've pushed academic collaborations, and industry, as Amitabh put it, is what are we getting out of it? And the pushback I've always given is that you don't put university in your critical path. If you're putting university in your critical path or in your strategy path, that's a mistake. They really should be orthogonal. They should be doing things that could come into your strategic path way down the line. And a lot of times, I think these collaborations tend to be industry looking for, oh, I need a neat algorithm to do such and such and such. Let's have a collaboration with this university. And those are fine, but they are short term. That's not, I think, what NSF is interested in funding or getting into. However, there is a role that industry could play, and I'm going to go back to something that I've hopped on from the very first session of the RCN, which is like making available to academia some of the tools that could make their research so much better. Today, doing anything with millimeter wave requires an immense amount of money, and it's kind of unrealistic to expect that most academics have that. And yes, you can say, okay, we will just have 5-star universities and fund them to get this really expensive equipment, and they will do the work. But I personally think that especially in something like channel modeling, crowdsourcing is what you need. You really want to be able to get devices out there that everybody can use to test channel models. You mentioned gesture recognition, Carlos. If you look at what's happened in Wi-Fi, ever since the Wi-Fi baseband channel impulse responses were made available to researchers, there's been an explosion of stuff that people have been doing with it. Today, in millimeter wave, we don't have that. If you want to do a channel characterization as an academic, you have to get your equipment and go out and make the measurements. Why do we still have that? That is where I think industry could really step up to the plate and say, you know what, we have these chips, we are doing channel characterization, we're just going to make these baseband outputs available to you, and go ahead and do whatever you want. It's a tool. That is the kind of collaborations, I think, that would really help academia do their ideas. You're not in the critical path of what industry is doing, but industry will benefit from what you can make available. So that's one way of thinking about it.
Just want to give Carlos some time to respond to some of the issues. If I think I heard you saying that you reached out to universities and you don't get much enthusiasm or responsiveness. Is that what I think that's what I heard you saying? No?
Me or
you?
Me.
So just want to just comment on that. Given that you're in the space of Wi-Fi, WiGig, and so on, and this is one of the topics that academia, love to work on. Students like these things because this is unlicensed band and so on. So I'm just wondering, what are the reasons? Given from our perspective, from academic perspective, we are very thirsty to know about problems in that domain. State-of-the-art problems that with or without industry funding, people would like to see these problems. Students, PhD students would like to work on them because these are very, state-of-the-art, good topics for PhDs.
So on that topic, I actually think that whenever I engage with academia, actually there's a very strong will on both sides to share information. It's just that I feel that, I do it on a very one-on-one basis. So I go to a university and then, you can only, you engage with that university and with those students. I think there's an opportunity if there was a forum that someone can come and speak to a broader set of people from academia, where you can actually say, this is what's happening. And look, last December, I happened to attend GlobeCom and to give a tutorial on 11, AY. Mm-hmm. And so just gives you an idea that it's a personal desire to actually spread the information so that people understand and they can get the, what's happening in the industry. It's not in any way to try to prescribe what the industry is going to do. As a matter of fact, there are many models of cooperation with the academia that go all the way from IP, but also go from just talent development. In all my engagements, actually, to me, it's all gifts and talent development. Mm-hmm. Because, I see the benefit of that, and I see, there's a return on that as well. But to Monisha's point, which I wanted to comment on that, Intel is one of those companies that has many of those chips already in the market. And by all means, we encourage folks to buy and use those chips. The challenge we've been having is that, we develop chips for commercial products, and those commercial products, they often use, in our case, operating systems like Windows, for example. And it's very hard for folks in academia to get a Windows stack, and it's very hard, to be honest, for Intel to disclose, look, this is my open source for the Windows, and go off and do whatever you want. So I think there is and we are one, but I'm sure others are in the same situation, other vendors. We are in that position where the chips are there. We can offer them, but we don't have a fully functional, at least at this point in time, Linux stack that you can do anything with the chip, and folks can go off and use it. That was the same thing with Wi-Fi in the beginning. Took some time. So is there an opportunity for academia to work with industry to, for example, enable that? Right? Some Linux development, give it a chip. There's the firmware, and a university goes off and develops the entire stack, and then you can go use and do your channel measurements, change the beamforming, do everything that we can do today with with the chip. So, we did get requests, but it's always that, there's that roadblock, right? Is there a place where NSF can facilitate, going from a chip to something that is widely available that anyone can use?
So, can I just add something? So one part which I've seen more companies doing, and I think Intel is doing it too, is eval boards when a new chip comes in. And I think those are actually pretty useful. In our prototype that we were building, we were able to use evaluation boards from, say, analog devices because, planting those chips is a little more work. And I think that is and I'm seeing more of it happening. And I think that's a very healthy development. And this would be a great place to advertise that. They're less expensive, less work, and you can play with them more. And then I think we could couple it with some of the test beds that are being developed in academia and also in as part of the Power platform to maybe build on that effort. So I would like your comments on that.
Yeah, and I kind of want to comment on that and take a little bit of what Carlos said and Manisha. I think one of the challenges from industry that we have is just support. Anytime there's something new that comes out, there's going to be bugs. It's going to be hard to use. There might not be full documentation. So if Intel comes out with a brand new chip and makes an eval board, it's probably not perfect and it's not working. And so I don't know how many people on the Intel side are available to help troubleshoot with those. And so that's kind of one of the roles that the SDR team at NI has taken on, is taking those early chips and turning them into products. And I've heard Manisha say it for the last several years that we want cheap millimeter wave. And believe me, we hear you and we're working on it. It does take time to get to something where we can broadly push it out to the masses and not just be overwhelmed with support, because we want to get it into academia, but that's been our biggest challenges for any of these kind of really pushing the boundaries next generation products. We have the ability to support maybe two different customers on it, and so our team is doing the best to do that, but we have limited bandwidth just because it's so difficult. And so there is a gap from when we're seeing some of these initial conversations to when we're able to push out something to the masses. But to your point, we're trying to take on, when we work with those initial users, taking that IP and creating something that we can either share or sell. We do have a business model to maintain, but at least get IP that we can distribute openly to give academics a starting point and couple that with some of the cutting edge hardware. So it takes us time, but we're working on it, and support's really been a huge challenge to get that.
So maybe I want to leave some room for the audience if they have any questions. Audience besides Akbar.
So I want to add one more thing there.
Let's see if there's somebody else.
One more thing to Sarah, and then related. So I think some academics may actually help facilitate that too. For example, not everyone, some people may want a more finished thing that there's plug and play. But, based on my experience in the last 5 years, we've been able to actually, build everything almost from scratch, an eval board. So I think there is an opportunity for some academic labs to work with industry, with eval board and stuff to actually move things forward. So I'd like to hear your comments on that.
I think the key word in that is some. And I think some academics, right? So yes. I think in industry, we are working with some academics. It's just not everyone. And to have it more widespread is difficult. It's not that we don't want to do it. It's just, it's limited. And I know, especially on our side, we do tend to keep things a little bit confidential until we have results. So we're working on projects, with what we call our lead users that not everyone even knows about. So we are engaged in those. It just isn't always public facing from a corporate side.
Yeah, all right.
So, any questions from the audience? There's a question there. Igor.
Well, I wanted to make a comment, and maybe this will also open a question. I think what we're missing also that all the conversation we have had is actually a path, a potential path to innovation, and that's how we should see this. And in Austin, we have been very successful in connecting research at the university with the startup community in the city. One of the reasons that Austin has been so successful lately in technology has been exactly that a lot of the work and the research that is being conducted at the university is actually translated into specific innovations through startup companies. And the good thing is that we are on both sides. We are working with the researcher, but then we can also work with the company once they have their own startup. So I think the trick here will be to find those mechanisms that would basically incentivize those collaborations. And it's not just between companies and the university. We also need to bring in the cities and the local government and the community. So the part of the effort should be also, how to, for example, if we have a smart city project in the city, how can we actually bring together government, universities, companies, and a community and put together a project that will have 5G, will have autonomous vehicles, will have e-health, will have all that infrastructure, but we need to create those mechanisms. And one of the things that NSF has been doing lately, which I've been personally involved, is also the NSF I-Corp and all those initiatives, even the PFI, the Partnerships for Innovation program. Those are programs that are actually promoting and incentivizing the relationship between universities and companies and industry. I think that's probably where we should be focusing on, how to create those mechanisms and then basically accelerate that transition to practice. That is the key for seeing some results from the research. If not, it's just research. If we want to see more out of research, then we need to do that. So I don't know if you have any comments about that, but that's what I wanted to say.
Thanks, Igor. Just to add to your what you said, I mean, there's also a program, Manisha is familiar with it, and several of us here, an NSF program, it's called IUCRC. I don't know if you guys are familiar with it, but it's Industry University Research Cooperative Centers. That is industry-focused centers. NSF provides some seed funding for it, and we've had 2 successful instances of that center over the years, I think, starting 2003. So there are several models, and this is just one example, where the government is putting some money and to push academicians and industry to come to the table and talk about industry-relevant problems. Again, looking at 3 to 5 year horizon as the ultimate outcome.
What I think we are doing in these forums, we are educating that how the 3GPP or 802.11 AY spec is looking like, what are the features of the spec. And there is open forum, all the documents are available online. And so I'll suggest the university look what is going on. It is all available, it is very transparent, and then come up with the problems which needs to be solved. So one example I gave is this interference alignment business. It is a very good topic, and you see there have been a lot of papers, but it is not practical because you need the full matrix of the channel to be fed back to make this work. So it is still an academic interest, how to make interference alignment work in a practical situation. That probably is a good topic to figure out rather than making all these ideal assumptions. So you get an idea what are the limits on the feedback bits from all the specification, and then make a proposal, say how interference alignment will work and what will be the performance improvement compared to other techniques like NOMA or something like that. So information is always available, and you see the ideas are, it is for everybody to generate new ideas. And if the idea is good, of course, it will bubble up, and the industry will adapt it.
So, yeah, so this is exactly how things are happening right now. So we are, so we are trying to facilitate that a little more. So I think I agree we should put more information from the, the NR standards. I think last time that generated a lot of interest. Now we got some more on AY, so I think we'll have more of that information on this website. And the key here is, I know that we should look at that information, but some of it could be facilitated. You point that you guys send me. I've never gotten an email from the steering committee saying, "Hey, this is an important document. Put it on the website," right? So share us, be proactive, point us, because there's a lot of information there, and create this channel. Now, relating to Igor's comment, yeah, there are lots of mechanisms: PFI, I-Core, SBIR. Lots of mechanisms, and actually they're part of the engineering directorate. I am on the same floor with those folks, so there we can do a lot more, and those channels can be done, and if there's new ideas, we can develop them there as well. But here we are going, all of the above are viable here. We are in the context of millimeter wave, different research communities coming in, and industry and academia. So now we are talking about more constructive ideas, so let's keep moving, yeah.
So as far as getting information about NR and what's going on the standards, I know my team, we put out a standards update probably once every 6 months. We typically do it through an IEEE Comstock webinar. I've seen some really good ones from other people like Keysight and Rode, and I think even Intel. But companies go and we put on webinars pretty often going over the standards updates. So if you guys are interested, by all means, just keep an eye out on the emails. Look around, I think Microwave Journal is another popular one. But the industry is doing very in-depth reviews of the standard. And those are good times to get in touch with people. You'll see the names of the people giving the webinars who are also good contacts for questions and fostering better communication between the standards, what's going on there, and getting it broadly spread out to the community.
Yeah, I've done some of those, but we can do more of that. That's a good point.
So any questions? Any from the audience? So one thing that I have in mind also that I think Amitabha brought it up, or one of the panelists, about the individual versus the collective expertise of this community. And you may be aware of what few people are doing and vice versa, but I mean, are we doing a good of a job in terms of letting everyone know what everybody else is doing, so that we can potentially form teams or tackle some big problems? So what's your perspective? I mean, this is our third meeting in terms of how we're doing in terms of exposing our expertise, and whether it makes sense to actually work on an individual basis with people or work in bigger teams.
I think the question was, this is my first time.
This is to all the panelists. It was brought up by Amitabha, but
I think Amitabha is probably more qualified than me too, since he's been here a few more times than I have. But being the first time that I'm here, I guess the first question that I have would be, is there a reflector? Is there a mailing list? People exchange information? I mean, how does it happen? I've been hearing a lot of comments from different people saying, make us aware, or upload a document or do something. But I don't know actually, right? Is there a place where, if someone
So we have a mailing list and we have a web page, and the mailing list is, I mean, as Sarah said, there are lots of updates that many of us may not really get. It would, we can work on that aspect easily.
Yeah, so the RCN website or whatever, you should have a link to say key things, right? 5G channel modeling document. There is a link you can get to that. You can go to 3gpp.org, where you will have summary of all the meetings, chairman notes, what are all the contributions which have been uploaded, what are the items. So any student working on a particular topic, go to 3gpp.org or 802.11 site to see what has been done in that area and then develop on that or come up with a brand new idea. So there should be some pointers in your website where you can refer to all the work going on. And then you have this quarterly conference where the experts come and tell what is going on in the industry. In that way, the students and the professor know exactly what to work on and what to improve and what are the new topics of interest.
So quarterly conference, what are you referring to?
RCN conference.
Oh, okay, semi-annual
So
conference.
there are links, and with all due respect, I asked all the steering committee members to send me, your company links. Nobody responded. So I have actually put some there, and I don't know when's the last time you looked at the website, but there are, and we could add more. But here I'll put a little more constructive. So we have 3 working groups now established related to these breakouts. One is networking and signal processing, and they've identified a concrete problem of, putting channel models and physical layer into network level simulation. And there's a lot of traction, and there's a few people who are really enthusiastic about it, and it's moving along. Yesterday, I think we got some interesting discussions on hardware and signal processing research, where we think we can move things along there as well. And then I think the standards today, it seems like there's an interest to kind of see how the NR and AY standards combine together to make them seamless. So I think there is already traction here. We are halfway through. So now maybe what we need is some a little more homework or input from the industry side to actually put some structure or what kind of problems these groups could address. Like hardware and signal processing, what could that be? Or what would be some interesting things to look at in terms of making the 5G NR and AY standards come on together? How could the community help? And I think that could be one way of thinking about, putting even some metrics for improvements as well.
So I guess the other thing, though, is, as they all pointed out, there's a bunch of stuff out there, right? It's just that for somebody starting out, it's hard to find it and all that. So the question would be, if the RCN website were sort of a repository of information and where people would sort of post their latest results, whether it's from industry or academia, there have to be people in charge of it, and maybe recruit volunteers from the student body. It has to be some sort of community effort to keep track of all the information that's out there. Because everybody, both faculty and industry people are super busy. They're not going to really do this, right? So it has to be some, They could at most provide some pointers every so often, right? That's
absolutely. And I think, so in the back, you can see that's the repository page right now. And there's quite a few links. And I think we need more engagement. So it is getting to the point where we can and have the community engaged. So I want ideas, and I think those 3 working groups are specific places where we could have some action items going forward. And some deliverables, different things to do for the next meeting, which we know is going to happen in New York.
So some of your panelists have to go catch a flight. So just, as a final remark too, having everything on a website is great, but as you mentioned, we're all really busy, and I don't know how often anyone actually comes and reads things on here. For me, just having recurring meetings and FaceTime with people is incredibly valuable. And just also, instead of maybe doing some of the posters, maybe we could even just pick 1 or 2 people to actually present and go over what topics they're working on. And you can have people from both academic and industry do this, just keeping a constant form of communication. So thank you for inviting me to be a panelist, but I'm going to run.
So I know at least Amitava has a flight to catch. So I want to thank you all so much. We can, I guess, stick around. Are we at 12 noon? So, 4 minutes. So I want to thank Amitava so much since he has to catch his flight. And Sarah too? Okay, Amitava and Sarah, so thank you. Thank So we can, you guys don't have a flight, do you? Yeah, there's a quiz towards the end, but okay. So let's see, are there any questions from the audience? I mean, we don't want to just dominate the discussion.
Let's make it more concrete. Are there some on the two working groups that are happening right now, or three of them? The standards, hardware signal processing, networking, and signal processing, those groups, can you think of some things, or you have some ideas to do something between now and the next meeting to move this, keep the ball rolling? I know that the leads have some ideas, maybe there's some additional.
Questions?
Just not exactly addressing what Akbar just mentioned, but to picking up on the idea of webinars. Carlos, you mentioned you actually go to certain places and talk to the students and all. One thing that maybe we could consider doing is having a webinar where you get a much wider audience through the RCN, that, you know, people, you have more often, you can reach a much wider audience if you do a webinar rather than show up at one university and talk to the students there. And not just Carlos, but people from other industries as well, because these meetings are great, but most of the time you really don't have the students, all the students from all of the academics represented here, and they are really the ones who need to listen to what you guys have to say. So that is one thing maybe, you know, can be included as part of the activities going forward, as part of the RCN.
Okay. Any comments from the panelists?
No, I mean, I agree, and you know, this can be done, I know this is millimeter wave, but this can be done for so many other things. And so many other topics beyond this, which, you know, if we have a forum, an industry can go and we can get people from different places, different groups at Intel to present on different topics. It's probably hard to do every month, but, you know, if it was something every quarter, or, you know, I think it's a lot more feasible to do. And vice versa, by the way. I mean, I think academic could do this likewise, present this is, you know, this is what I'm doing as well.
Questions? Akbar, do you have any questions? I'm sure he does.
Any comments, especially from those working groups or the leads? Yeah, Arjuna?
Arjuna Madanayak. So we were thinking about establishing a small working group from participants of the RCN that deals with some of the hardware complexities, the circuits and systems aspects of a millimeter wave transceiver. So the idea is that can we build fairly well understood mathematical models that could be used for designing some of the transceivers at these higher frequencies. So if someone is interested in contributing to that effort, contribute to some of the power amplifiers or mixers, the modeling of that, to look at this whole system end to end in a more closed form way, we have some interest in that. The other thing I wanted to say was, we didn't really talk about the role of artificial intelligence and machine learning in 5G. So I think that's a big open question. If there's interest in that, I think that's something that's we can look at next time. Thank you.
Who else we have from the members of the working groups?
The one thing you can learn from the machine learning community is how to sort of stay engaged and move the field really fast.
Right.
Maybe too fast, but forward, right? They're really sharing information at a really crazy rate.
Right.
I think we can learn from that.
I mean, machine learning is applied for a lot of fields. So RFIC is something that we haven't really looked at. Can we combine some of the knowledge from machine learning to improve 5G and other circuits and systems at a more hardware level? I don't know the answer. So.
Thank you. Do we have anybody else from the leaders of the discussion groups? Okay.
Yeah, I have one question, since it popped up on the screen here. The new licensing procedure from the FCC, I was an early adopter of trying to do that about 3 years ago and totally failed because the FCC was not ready to accept applications, even though has anybody had success in following their new procedures?
Yeah, I guess the question is implementing the FCC procedure.
Right. Has anybody submitted an application for a program license and been successful?
Anybody from?
So I did do the older way, and it was actually not too bad. So, and the newer way is easy. So
the older way for me flat out did not work.
How long ago was that?
I said the older way, right after they passed the law.
This is the mic.
I'll speak in the mic. The original way that they had no procedure, absolutely none. So I submitted applications, and after going around in circles for about 6 months, I finally said, I will be glad to wait until you have a procedure.
Any questions? Reply to it.
I'm trying to get to a website.
I think the Wi-Fi is not connecting here. I think not.
I think it was, but that's how I'm getting to the RCN website.
I have a question for Carlos. So in our standards breakout yesterday, we discussed a lot about like how the two standards can actually, like the 5G NR and 8.11ad and AY, can actually learn from each other and then kind of like actually collaborate, or is there a sort of possibility for coexistence? So for example, as you said that for 5G, it would be probably like they will be targeting 28 gigahertz band first, but then there is also this incentive for 5G to sort of like also help in 8.11 AY that for the indoor environments that we are targeting. So for the base station, it's very hard to actually route inside, and we saw in some earlier discussions that they are thinking about putting another hop. So if it is a multi-hop to get to those indoor environments, so I think that could be a good venue where the two standards can collaborate and then can influence each other. So my first question is what these standards can 8.11 AY and 5G learn from 8.11 AD, because it has been out there for 6 years. And then despite these sort of challenges of like different sort of markets that they are addressing, what are the still some points on which the two standards can collaborate in terms of like sharing resources, hardware? So your points on that.
It's a great topic. I think it's good to put perspective on this discussion, in the sense that until a few years ago, right, there was a separation between licensed and unlicensed, and then until the point where there were new technologies like LTU and LAA that came into the 5 gigahertz. And I do believe that, that to some people in the unlicensed community, that came as I don't know, I want to say as a shock, but as a surprise. And I think the industry at that point, I think they started at the wrong footing. I mean, and there was a lot of miscommunication, and there was a lot of arguments, public arguments, and the FCC had to monitor the situation, and we all know the history, how that went down. I do believe that we learned a lot from that. I think we are, as an industry, in a much better situation now, where, I see a lot of communication happening. Before it was, every company would have an unlicensed division and a licensed division, so to speak. Folks that are doing, connectivity, the Wi-Fi, the Bluetooth, and another business unit that is doing the cellular. And there will be very few interactions and very little communication between those groups. The situation has changed today, where maybe as a result of it, but of this coexistence situation, but not only just that, just the fact that there needs to be more integration and more reuse in terms of elements on a platform. So there was a need over time to have more communication, which is happening today, and more reuse. So, and that has happening not only at Intel, but it has happening at every other company that builds communication chips. So the industry is in a much better situation now. So I do believe that for millimeter wave, that we are in a much better position to do something that, instead of like it was for 5 gigahertz, that was not much coordination, but where we actually start from the right with the right discussion, with the right starting point, so that we can get a solution that makes sense for the 3GPP use cases, makes sense for the connectivity, Wi-Fi use cases, but at the same time, they are able to, be fair with each other. I think the issue, quote unquote, issue that I see, which is not really an issue, just a timing issue, is that the NR standard for the unlicensed millimeter spectrum, in this case 6 gigahertz, it's not there yet. I mean, it's not something that, if you talk to the industry, it's not something that they are spending a huge amount of time right now. They are spending most of their time in trying to figure out the NR standards for 28 to 39. And that's the focus, and that's where the resources are going. Discussions for NRU in 6 gigahertz, they are just starting. I mean, it's really at that point that they're trying to get agreement that, yes, we should be doing NRU for 60, but I don't think there's been enough discussion on what exactly that's going to look like, which is a good thing because that's the time to engage. So I guess responding to your question, in summary is, I do believe that we're in a much better position. I do believe we have really a possibility to come up with something that can really be better than what we've done in the past for other bands. But it's very difficult for me to speculate right now because we are really at the early stages of that process.
So what would it take to actually take a different starting point and make the AY standard a bit more agile? Right now, it's still just sort of predicated on really, nodes that are not moving or are slow moving and things like that. So what would it take to make for AY to take the initiative and then create a mobile solution instead of waiting for the 3GPP guys?
That gets into a discussion that's not technical, it's more business related. Yes, 11AY could, from a technical perspective, we could say, you know what, let's do more frame-based, short, slots, and have a more agile system. And we could spend 3 years doing it and come up with a standard. But then the question is, would that actually get adopted by the cellular community? And just given the dynamics of how the history has been on the cellular side, I think the likelihood of that happening is low. And so I think the something that has a much higher chance of success is instead if 11AY 3GPP would be able to agree on some common signaling, on some common and I'm going to make perhaps a statement here that it has not been discussed, but just something in my mind, right? Can we agree on a common preamble? Something that both standards can use, and that would ensure that they can each detect each other, and with that common preamble, then they can defer whenever whenever they have to defer, and then they can do their own thing. Okay, I think that's a more viable path than trying to say we're going to have one standard that's going to do everything, and the other side is going to say yes, we'll take that.
So there's a question there.
Yeah, I just had some comments on kind of the sharing of information and in this field. It seems like, this whole workshop is very focused on kind of a vertical development of, 5G. So everything, from devices up to networks, and we have all these different working groups. But, in academia, the way we share a lot of our information is through these more formal, like peer-reviewed conferences. And those tend to be more horizontal. So you have, your circuit conference and your network conference. So maybe one action could be to look at developing a formal peer-reviewed conference that covers everything from devices up to networks, but is focused explicitly on 5G millimeter wave communications.
That's a very interesting idea. I think that's. I mean, you're probably aware that there are several conferences and workshops on millimeter wave, but you're correct. I mean, they focus on certain aspects of millimeter wave, 5G, hardware or 5G protocols and channel access and so on. Any other questions? Any last comments, thoughts? Okay, well, if there are no other questions, I think we can conclude the panel. Let's thank our distinguished panelists, and thank you so much. Oh, did you want to make a comment about the Channel Modeling Alliance? I think somebody, Akbar or Katie?
Just do it from here. Yeah, someone I guess was the first breakout session report said that it would be very nice if there was a place where researchers had access to data. So NIST has created a website. The link is right there, 5gmm.nist.gov, where we are uploading data sets that are made by different groups with millimeter wave channel sounders. So some of the NIST data is up there. We've got 3 or 4 other data sets, but we're hoping to have that populated with more and more data as the months and years go on. But right now you can access the data and download it yourself if you're interested. On this particular page, I didn't see the link to the data. So if you have trouble finding it, go ahead and just send us an email. There's some contact information at the bottom of the page there. But yeah, some of the submissions that are referred to at the bottom of the page, those are the data sets.
So Katie, just to clarify, these are data or there are also models that have been developed based on this data? Is it just the data or are there any models already?
Okay, yeah, I think these are just data at this point. I think there is a place to upload models and maybe there is 1 or 2 from NIST. But each of the, and this is a good point, each of the data sets has associated with it a parameters worksheet that describes the measurement conditions, so frequencies, frequency band, just a whole host of metrics related to the channel sounder itself, and then an environmental parameters worksheet that describes the environment where the measurements were made in detail. Maybe we should take a second to, yeah, the GSM. Since I've got the mic, and Akbar just offered, in Boulder, so this is this data repository is part of this 5G millimeter wave channel model alliance that NIST is coordinating. And it's a very nice group. Many of the folks here are part of this alliance also. It's open to anyone, but we get together and we're focused mainly on measurements, so the channel sounder aspect of millimeter wave channel modeling. And then there's a group that's focused on channel models themselves. So I encourage everyone to visit the website and feel free to join. There's no membership fee or requirements or anything like that. Then NIST is hosting this 11th Global Symposium on millimeter waves. So this is a separate activity from the Channel Model Alliance. But I'd also like to encourage, this is sort of the right audience, the academic community, industry folks who are interested in millimeter waves. It's a little broader than just communications, but because we are hosting an IEEE 5G summit, the focus there will be on communications. So it's a 3-day conference in May in Boulder, Colorado. And as I mentioned, the first day includes a 5G summit where we'll be talking mainly about hardware issues because this is the same week as the ICC. So we'll be focused mainly on hardware. And then there are parallel tracks, so day 1, 2, and 3 with 2 separate tracks covering things like antennas and terahertz and sub-terahertz and sensors, Internet of Things, emerging technology. So there's a whole host of topics that you can find on the website there. The call for papers, the paper submission deadline is the end of this month, January 28th. And all that's needed is a 2-page abstract, sort of an extended abstract. The final papers aren't due until March. So anyways, go ahead and take a look at this website, also gsmm2018.org. And if you have any questions on either of those, just send me an email. I'm involved in both of them. For the Friday of this week, we will also have a face-to-face meeting of the Channel Model Alliance. So that's what's going on at NIST.
Thanks, Katie.
Thanks.
Did you say extended abstracts or full papers?
What's due at the end of this month is just an extended abstract.
And then later on there's
And later on there'll be a paper.
Okay.
That's right.
I think we have some further announcements regarding the upcoming meeting, and I'll let Akbar talk about them.
Yeah, thanks. So yeah, a couple of, one going to Greg's comment, I think definitely there was mentioned by several folks that, it'll be useful to have new venues where this system level work can be published and exchanged. So conference would make sense too, but right now there are special sessions of at Globecom and VTC that are happening, and we have done from the Channel Modeling Alliance, where initially the focus was on channel modeling, but then we broadened it to system level things, and we've been advertising it to the mailing list. So we'll be doing that, but maybe there is a place for a dedicated conference that we could do as well. Now, I announced yesterday, I think the next meeting is going to be in Brooklyn, New York on July 11th and 12th. 11th and 12th or 12th, 13th? Yeah, 11th and 12th, but I'll send an email. But it's July, either 11th, 12th, or 12th, 13th. And so please mark that date, and we will definitely have a follow-up on some action items, especially for the working groups and maybe even some of the discussion here to maybe do have some different format also, activities for the New York meeting. And yeah, so... And Sandeep Rangan will be the local host, and then Marco Metsuia is going to be involved with that as well. So, yeah, any other questions or? So I guess we could, should we, Marwan, so it's 11:45, so lunch break around, or 12, yeah, and then 1 o'clock, the NI workshop would be right here. So for those of you who are here, please do check it out. And thank you again for coming to the RCN workshop. And I hope you learned something, and there'll be more things happening. And we're always looking for people to keep the ball rolling. So for each breakout sessions, there are already a critical mass of people who are involved. And if you're interested in participating, there'll be follow-up emails, and you can be engaged in it and voicing and contributing to how those efforts move along and any ideas you may have. And also, there'll be follow-up on how you may share more information on the website and send us the links. Okay, thank you very much.